Have you wondered what an AI agent is?
Have you heard of terms like tools, system prompt, and chain of thought?
Well, keep watching and we will bring you up to speed on how to build your first AWS AI agent.
Hi, I'm Banjo.
Hi, I'm Olivier.
In this video, we'll walk through how to build an AWS Solutions Architect AI agent.
Our agent will be able to cite the AWS well-architected framework and deploy Lambda functions.
We will go through how to use Amazon Bedrock, LangChain, and Streamlit to put an agent together. First off, let's define what an agent is. An agent is an application powered by a large language model, LLM, with a predefined instructions on how to act. The agent has a set of tools which are self-contained functions designed to perform a specific task. Our agent is a helpful solution architect that can help customers build solutions on AWS.
So let's start by building a tool for our agent to cite the well-architected framework. So you may know the AWS well-architected framework. It's a set of best practices that we encourage you to follow. And what we're going to do is that we're going to ask our agent to learn it and to cite it. So I built this Python code where you can see these URLs. So the well-architected framework, they have this set of sitemaps, XML, and if you look at one of them, it's just a set of URLs with all the pages. So if you open one of them, it's just like a normal page. And we're going to feed the agent with all of these pages. So if you look at my code, what I'm doing, I have all these URL. I'm going to loop through them, and I'm going to extract the text. So I'm going to just extract the HTML here. I'm going to chunk it and to put them in small pieces of code. And then what I'm going to do is I'm going to use Bedrock embedding. So here, as Benjo said, we are going to use LangChain. So I'm going to create this Bedrock embedding object. And here, again, I'm going to loop through the small chunks of text I've created. And I'm going to put that in a vector database. And then when I have it, I'm going to save it locally. So here, I'm just saving locally my vector database. And if you go here, it's actually saved in my local index folder. Now that I have that, I have my vector database, which learned from the well-architected framework with all the URL. And I want to see if it works. So I have this tool here, and I have a function called AWS well-arch tool. And it's taking a query. So a query can be how can I, secure a VPC, for example. Any question you may have on AWS that the answer is in the AWS well-architected framework. So what I'm doing, I'm again using Bedrock embedding. I am loading the same vector database I just created, and I'm going to do a similarity search. So I'm not going to go into details how a vector database does, but basically here is going to search for terms in the database that have the same meaning of what I want. And then when I have that, I'm just going to create a new prompt. So my prompt is going to be use the following pieces of context to answer the question at the end. I'm going to put the context. So the context is basically what I got from the vector database. I'm going to put the question again, which may have been how can I design secure VPCs? And I'm going to call Amazon Titan. Amazon Titan is another LLM created by AWS. And I'm going to call it with this new prompt. And then he's going to answer me like any LLM would do. So, and I'm then returning the new answer, and also the links that were used to generate this answer. So the links of the well-architected framework. And then I just send that back to my main function. So let's try it. So here I have that, and I have my test tool. So basically, I'm just saying, okay, how can I design secure VPCs? So if I code that, ta-na-na-na, yes, so you have it. So it's sending the new prompt, which is not there, and you have it. This is the answer it gives me. So create multi-layer network and create multi-layer networks. Here's some documentation, and it gives me the documentation related to my question in the well-architected framework.
Thanks a lot for that, Olivier. Let's go on to the next tool where we're going to have our agent deploy actual AWS Lambda functions. Let me go to my code here. So this tool is going to be able to, we're going to ask the large language model to actually write the code, give us a function name for the code, a description, and if there are any external Python libraries needed for this. So right now, it's just creating Python code. It's very important to restrict what your large language model can do because you don't want to give it too much space to do things. So I'm focusing this as on creating a Lambda function that run Python and able to just, instead of trying to do JavaScript, Java, just focus the large language model so it can do what it can do best. From there, once it gets the code, it can create external dependency packages. I'm hard coding some resources, so I'm always going to have something like agent AWS resources, upload the zip file. I predefine an S3 bucket where it's going to deploy that code. So I'm creating an environment where the large language model can operate without giving it too much space. So constrain the model to do what it does best. And once it deploys the function, it's going to say, this function was deployed to the customer's account. I'll provide the answer. So let's see how this actually works in practice. So I'm going to ask my agent to create a Lambda function that can generate a random number between 1 and 3,000. So when I send that query to the agent, it's going to be thinking about, OK, what are we doing here? So thinking. OK, so it understands. So we can look what it thinks. So this is what we call chain of thought. The agent is understanding, I got this request from a user. What can I do? So it's going to say, it's going to write the actual code for that. It gives us a function name, random number generator. It gives a description, and there's no external libraries needed for this. So the agent was actually able to understand that. It deployed that to the AWS account, and it's now thinking about how to respond to its final answer. So we can actually go to the actual AWS account while that's thinking and see if it created the function. So yeah, we got this new random number generator account. And we can see this return the code. So this is a very simple example. It's just returning a random int. But you can see how providing the guardrails for the agent to act, it's able to use this tool to generate code, deploy it, and actually call this Lambda function directly to my AWS account. It got some errors there, but we were able to deploy the code. So agents and tools are still working through, but it is exciting, and I'm excited to see what other type of tools and what agents can be built.
Thank you very much, Benjo. So now let's see how we can actually connect an agent to this Lambda function. OK, so I'm in my AWS console here. I'm going to go to Amazon Bedrock. Let's get started. And here you have the agent menu. So let's go to the agent. And that's where I'm going to create an agent. So let's create one. I'm going to give it a name, agent AWS. I'm going to give it a description. So AWS Agent is an automated AI-powered agent that helps customers with knowledge of AWS by querying the AWS well-architected framework and writing code. That's what we did earlier. Here I'm going to select my role. So the role, just a few tips, it has to have this pattern, Amazon Bedrock execution role for agents _. Then you put whatever you want, but it has to look like this. And let's create the agent. Then you can choose which LLM you want to use. So here we're going to use Anthropic, and you can choose which version you want. We can use the V2. Let's use the V1 here, for example. And we have to put a sentence to introduce the agent. So here, I'm going to say you are an expert AWS Certified Solutions Architect. Your role is to help customers understand best practices on building an AWS. And you will provide links to documentation to support your answers when you have them. So basically, this is going to be sent to the agent before every query I do. Next, no action group, knowledge. And there I have it. I have an agent. So when you have an agent created, then you can, directly ask it questions. So here I can ask, how can I design secure VPCs? And remember, right now, this agent is not connecting to anything. So it just basically doesn't know anything. It says, sorry, I don't have enough information to answer that. So if we want to connect our agent to the code we wrote earlier through a Lambda function. So what I'm going to do, I'm going to go to the working draft here, which is my current version of the agent. And I'm going to add an action group. Here, I'm going to call it agent. And I'm going to select the Lambda function that is actually calling the code that we wrote earlier. I have to give it a open API schema editor. So the OpenAI specification defines a standard language agnostic interface to HTTP APIs, both for humans and machine, and that's what is going to be used by my agent to kind of determine which API it has to call, which endpoint it has to call. So I store mine in a S3 bucket. So I'm going to get it. If you want to see what it looks like, I can briefly show you. So this is what a OpenAPI JSON looks like. So you have descriptions for every endpoint, and that's how the agent is going to see, okay, when he asks me how to design secure VPC, that's the endpoint I have to call. Okay, adding this. I have to click prepare of my agent. And now, normally, if I call my agent again, how can I design secure VPCs? This time, it's going to call my Lambda function because it knows that this question relates to something he found in the OpenAPI JSON. It's going to answer using this. All right, I have an answer. I even have some links related to the well-architected framework. And I have it. My agent now knows how to use the AWS well-architected framework to answer me. And there you have it, an AI-powered solutions architect agent. This is just the beginning. We can add and update the tools as we find more use cases.
Yeah, like how about creating AWS diagrams? So, if you'd like to learn more about AI agents and some of the servers we have covered today, check out the links in the description. If you enjoyed this video, give it a like.
And if you want to learn more and see more hands-on technical content, be sure to subscribe to the AWS Developer YouTube channel. Thanks for watching.